What if I told you the monsters in Stranger Things aren't the scariest part? It's the show that made synth music cool again and made us all terrified of flickering Christmas lights. Stranger Things is a cultural phenomenon, but here's what keeps physicists up at night. Beneath the nostalgia and the demogorgons, the entire plot rests on one crucial scientific concept that's actually real: the gate. A doorway between our world and the upside down. In Season 1, Mr. Clark casually explains this using a paper plate and a tightrope. In 3 minutes, he introduces millions of viewers to the concept of a wormhole. Most people thought it was just clever sci-fi storytelling. They were wrong. Because here's the thing. Albert Einstein predicted this exact phenomenon over a century ago. Not alternate dimensions full of monsters, but literal tears in space-time that could connect two different points in the universe. And some physicists believe they might actually exist. So this begs a massive, spine-chilling question. Is the gate just convenient television magic? Or did the Duffer Brothers accidentally tap into real, terrifying physics that could theoretically rip our reality apart? Today, we're separating the science fiction from the science fact. And trust me, the truth is just as disturbing as the fiction. To understand the upside down, we have to throw out Newton and bring in Einstein. And trust me, what Einstein discovered is way stranger than anything in Hawkins, Indiana. Before Einstein, for over 200 years, we thought space was just an empty stage where stuff happened. A void. Nothing. But in 1915, Einstein's theory of general relativity completely shattered this idea and revealed something mind-blowing. Space isn't empty at all. It's a fabric. And here's where it gets wild. This fabric is stretchy. Picture a trampoline. Now, place a bowling ball in the center. Watch how it warps the surface, creating a dip. That's exactly what massive objects like stars and planets do to space itself. The sun, for example, is so massive it creates a gravitational well that keeps Earth orbiting around it. We're not being pulled by some invisible force. We're literally rolling along a curve in space-time created by the sun's mass. But Einstein didn't stop there. If space can bend, he theorized it could also fold. And this is where the upside down becomes eerily possible. Imagine our universe as a flat piece of paper. You're at point A, and your friend is at point B on the opposite side. In normal space, you'd have to travel the entire distance, maybe millions of light years. But what if you could fold that paper so point A and point B touch? Suddenly, they're right next to each other. Now punch a hole through that fold. Congratulations, you've just created a wormhole. In physics, this isn't called the gate. It's called an Einstein-Rosen bridge, named after Einstein and his colleague Nathan Rosen, who mathematically described it in 1935. And here's the kicker, the math actually works. These aren't just sci-fi fantasies. They're legitimate solutions to Einstein's field equations. The universe's rulebook technically allows them to exist. But here's the reality check that physicists don't want to admit on camera. While the math for wormholes is beautiful and elegant, actually building one would break almost every rule in the cosmic playbook. Let me break down the 3 massive problems. Problem number 1, size. When Einstein and Rosen first calculated these bridges, they discovered something disappointing. Natural wormholes, if they form at all, would exist at the quantum scale. We're talking smaller than a single atom, smaller than a proton. We're talking about diameters measured at the Planck length, 0.0000000000000001 meters. You aren't fitting a demogorgon through that. You aren't even fitting a single molecule through that. Problem number 2, stability or the lack of it. Even if you somehow found or created a wormhole, it would have the lifespan of a hiccup. Physicist Kip Thorne, who won the Nobel Prize and consulted on the movie Interstellar, proved that any wormhole would collapse on itself almost instantaneously. The immense gravitational forces pulling inward would pinch it shut faster than light could travel through it. We're talking nanoseconds, microseconds if you're lucky. The tunnel destroys itself before anything can use it. Problem number 3, the exotic matter problem. And here's the truly bizarre requirement. To keep a wormhole open, to prevent that catastrophic collapse, you would need something that shouldn't exist. Negative energy density, also called exotic matter. Think about that for a second. Not just no energy, not zero, negative energy. This is matter that would have anti-gravitational properties. Instead of pulling things together like normal gravity, it would push spacetime outward, propping the wormhole open like invisible scaffolding. In our current understanding of physics, we have no way to create or harness this. Some quantum effects, like the Casimir effect, produce tiny amounts of negative energy at microscopic scales, but nowhere near enough to stabilize a human-sized portal. But in Stranger Things, 11 is the exotic matter. Her psychic power, whatever that energy actually is, acts as the negative pressure holding the gate open. The Hawkins lab didn't need theoretical physics or impossible technology. They just needed a girl who could bend the rules of reality itself. In a weird way, the show actually got this right. You would need an external source of exotic energy to maintain a stable portal. The Duffer Brothers did their homework. But here's the most terrifying aspect of wormhole physics that Stranger Things hasn't fully exploited yet. If you connect 2 points in space, Einstein's equations reveal something chilling. You might also be ripping open 2 points in time. This isn't speculation, this is math. The upside down is frozen. We know the upside down is stuck on November 6, 1983. The exact day the gate opened. Most fans think that's just creepy set design. But physicist Kip Thorne proved that wormholes can create time desynchronization between their 2 ends. One mouth exists in 2025, the other, trapped decades in the past. The gate isn't just a doorway to another dimension, it's a doorway to 1983. And here's what makes this absolutely bone-chilling. Many physicists argue that any traversable wormhole inevitably becomes a time machine. It's not optional. It's baked into the physics. Which means if the Hawkins crew figures this out, if they navigate that gate correctly, they could travel back to November 6, 1983, and stop everything before it starts. Will never vanishes. Barb never dies. 11 never opens the gate. But here's the nightmare scenario. If they prevent the gate from opening in 1983, they erase their own reason for going back. If they never go back, the gate opens. If the gate opens, they go back to close it. The loop never ends. This is called a temporal paradox, and some physicists believe attempting to create one would cause the wormhole to catastrophically collapse, killing everyone inside and potentially tearing a hole in space-time itself. The Duffer Brothers have accidentally set up the ultimate cosmic horror. A door to the past that could unravel reality if anyone tries to walk through it the wrong way. The upside down isn't just hunting the kids. Time itself might be the real monster. So here's the final verdict. Is Stranger Things scientifically accurate? Shockingly, yes. More than it has any right to be. The Duffer Brothers took Einstein's century-old equations, added just enough creative liberty to make it work on screen, and accidentally created one of the most scientifically plausible portals in television history. The gate isn't just cool-looking CGI. It's theoretical physics with a Netflix budget. The wormhole math? Real. The need for exotic energy to hold it open? Real. The temporal displacement freezing the upside down in 1983? Disturbingly real. But here's my question for you. What if Season 5 goes there? What if the final battle isn't just about closing the gate, but about when to close it? What if the gang realizes they've been sitting on a time machine this entire time, and the only way to save Hawkins is to risk tearing reality apart? Would you take that chance? Would you step through a wormhole knowing it might erase you from existence? Or trap you in 1983 forever? Drop your theories in the comments. Is the Upside Down a time trap waiting to be weaponized? Or is time travel the one line the show won't cross? And if you want more breakdowns where we dissect the science behind your favorite shows, hit that subscribe button. Because next time, we're tackling whether Interstellar's black hole could actually exist. Thanks for watching. And remember, sometimes the scariest monsters aren't the ones with teeth. They're the ones written in equations.